Okay, section 3.5, implicit differentiation. Differentiation just means you're taking a derivative. If you're differentiating, you're taking a derivative. Implicit, what does that word mean? Implicit differentiation. Let's talk about that. So there's two ways we can write a function or an equation here. We can write it explicitly, or we can write it implicitly. So an explicit equation is what you're used to. It's really pretty. You have a variable isolated on one side of the equation, and then the other variable is on the other side of the equation. So you've isolated a y in this example, and then you have the inputs on the other side. It's really pretty. Okay. I know I could write this as saying that I have a function of x here. All the x's are on that side. It's very organized. An implicit equation. With an implicit equation, your variables are mixed up on the same side of the equation. Okay? Sometimes you can take an implicit equation and you can rewrite it explicitly, and then your life gets way easier, right? If I wanted to know what y prime was, and the original equation says y equals, then it's really easy to take the derivative. But sometimes the formulas we work with or the equations we work with in business and in calculus in general are so complicated. They're written implicitly with the variables all mixed up. It's too hard to isolate one variable. It's too hard to get y alone. So we have to work with the equation as it's given to us. We have to find the derivative the way the function is written or the way the equation is written. And it's tricky. It takes organization. It takes keeping things straight in your brain, like what's the function, what's a variable. So be very patient with yourself. Deep breath. I have some notes here. I'm not going to go through them. They're just for you to reference later. It's all things I'm going to say today in class. So we're going to start with this basic example. Okay. So it says, consider the following implicit equation. Again, implicit means that the variables are all mixed up on the same side, right? So what we're going to do is we're going to find the derivative two ways. First, because I can get the y alone, we're going to get the y alone and then take the derivative. And second, we're going to work with the equation as it's given to us and then get the y prime alone. So I'm just showing you the two ways it can happen here. So let's take a look at this. It says, consider the following implicit equation where y is a function of x. Okay, now that's important. Where y is a function of x. Y can be written as a function of x. Or sometimes you'll see instead of the f of x notation, they'll do y of x. But you still read it the same way. You're going to slow your brain down and say, oh, okay, wait a second. If this is true, then my x, that's my input variable, and the y is a function. So you really have to know how to read function notation in this section. So x is a normal everyday variable and y is the function. Okay, so let's find this derivative two ways. So the first way they want me to find the derivative is I'm going to find y prime by first solving the equation for y, because we can. Okay, so let's do that. I can get this implicit equation. I can rearrange it to make it say y equals in one simple step. All I have to do is subtract 3x squared, right? From both sides. And now I have an explicit equation. So see how easy it was to get the y alone? Now I can take the derivative of that, no problem. If y is equal to 2 minus 3x squared, then what's the derivative of y? Well, the derivative of 2 is a constant. I'm going to do my power rule over here. I'm going to get negative 6x to the first, so don't write it. So y prime is negative 6x. So if you can get the y alone, do it. because then you're more comfortable. This is what our derivatives have been looking like, right? But I just want to emphasize here, when we're doing this, we're taking the derivative of the left-hand side. The derivative of y is y prime. And then I took the derivative of the right-hand side, and I got my derivative. So you're taking the derivative of both sides of the equation. The derivative of y is y prime. The derivative of that polynomial was negative 6x. Okay. Oh, did I hear a chime? Let me see. No. Okay, sorry. I thought I heard a chime over there. Okay. So now we're going to find the exact same answer, but we're implicitly. We're going to work with the function as it was given to us. So we're going to take 3x squared plus y equals 2, and we're going to take an implicit derivative. Implicit derivative. So I'm going to take the derivative of the left-hand side and the derivative of the right-hand side. But when I do that, if I'm trying to find y prime, okay, and y is a function of x, when I do this, I'm going to have to treat x like a variable because it's an input variable, right? Okay, heard a chime. Hold on real quick. Oh, I thought I heard, oh, here. Oh, there was a thing. So Jocelyn, yes, A, the first part was just basic algebra solving for y, and then I took the derivative. Now I'm going to take the derivative the way it was written, and then we'll do some algebra. We're flipping it. And yes, that's correct. Thank you, Renee. Okay, here we go. So when we're solving it as it's given, you're going to have to stay really organized. You're going to have to say, what's the variable? What's the function? Or what are my letters representing? What is this x representing? What is the y representing? So if I'm looking for y prime and we're told up here y is a function of x, okay, that means we need to treat x like a variable. That means if I take the derivative of plain old x, what's the derivative of a plain old x? It's just a 1, right? Yeah, just a 1. But I'm going to treat y like a function. That means when I take the derivative of y, it's not a plain 1. I'm just going to write y prime when I take the derivative of y. It's not 1. I don't know what it is, but it's not 1 because it's not a plain old variable. Y is not acting like a variable here. It's a function. It's just implicitly written. So let's go ahead and take the derivative of each of these. So I'm going to take the derivative of this first term right here, 3x squared. So I'm going to do my power rule. So that's going to be 6, rewrite my base, decrease the exponent by 1, and technically tack on the derivative of the base, right? But since I'm treating x like a variable, this derivative is a plain old 1. So this right here is just 1, so I'm just going to get 6x. And we don't write that exponent 1 there, okay? Plus, then in the next term, I have a y. I'm treating y like a function, so when I take the derivative of that, I'm going to put y prime. And then I have to take the derivative of both sides of the equation. So now when I come over here and I take the derivative of 2 is a constant. And what's the derivative of a constant? 0, right? So I took the derivative of every single piece on both sides of the equation, treating x like a variable, y like a function. But I'm supposed to find y prime, right? So I'm being told to find y prime. So I just have to solve for y prime now. I'm just going to subtract 6x on both sides. So let's go ahead and do that. Bring that up a little bit. Okay. So when I do that, I'm going to get y prime is equal to negative 6x. I get the exact same answer as before. I just found the derivative as it was written. I found the derivative implicitly. Now, on this function, you have a choice. You could solve for y. You could do algebra first and then find the derivative explicitly. That's fine. Or you could work with the function as is and find the derivative implicitly and then do algebra to solve for y. You have some options here, but sometimes you'll have to do an implicit differentiation. You won't have any other choice. Okay, let's do another example because right now you probably have no idea what's going on. So let's do another example. Okay, here we go. We're going to look at this equation. This should be familiar from college algebra. Not sure if business math does it, but it's an equation of a circle. You don't have to know that to do the problem, but it's an equation of a circle where the center is the origin and the radius is 5. But you don't have to know that. We're just going to find the derivative implicitly. Implicitly. And the reason why I have to do it implicitly, don't write this down, but if I try to make this explicit, if I tried to get the y prime alone, the y alone, if I tried to do that, I'd have to subtract the x squared on both sides, right? That's fine. But then I'd have to take the square root of the left side and the square root of the right side, and the square root principle says it's the positive or negative root, because if you square a positive number, you get a positive, or if you square a negative number, you get a positive. So then it no longer becomes a function. When I take the square root of both sides to get my y, I would no longer have a function. So we can't find this derivative explicitly by getting the y alone first. We have to do it implicitly. Plus, you were told to do implicit, right? So you don't have a choice. If you're told to do implicit, you got to do implicit. That was just a little reminder from algebra there about the square root principle. So even if I wanted to, I couldn't solve for y and do this implicitly. So we're going to have to take the derivative as is. That means we're going to have to be organized, guys. So here we go. So we're going to have to use every little clue they gave us. We're going to have to use this clue right here to think about what is y acting like, what is x acting like. So x is my input variable. So that means we're going to treat x. So that means treat x like a plain variable. That means if I take the derivative of an x, it's the plain old x, it's going to be a 1. And that means my y is acting like a function. So y is a function. Y is a function. So if I have y prime, it's not going to be a 1. Okay, so here we go. We're going to take the derivative. We got this. I'm going to take the derivative of the left-hand side. I'm going to take the derivative of the right-hand side, piece by piece. So here we go. I'm going to take the derivative of x squared. So I do my power rule. I drop my exponent down to the front. That's a 2. I rewrite my base exactly like I see it. I decrease the exponent by 1, but I'm not going to write that. And technically, I tack on the derivative of the base. Right? But we're treating that like a plain old variable. So this derivative of the base is just a 1. So I don't have to write it. So I just get 2x there. Normal, everyday, regular power rule, chain rule, not necessary. Okay, but now we go to this next term. It's a base raised to a constant exponent, so you're going to do your power rule again. So I did power rule on the first one. I'm going to do power rule on the second one. I drop my exponent down to the front. So that's a 2. I rewrite the base exactly like I see it. I decrease the exponent by 1, but I'm not going to write that. Then I tack on the derivative of the base. Do I get to make this derivative of the base a 1? Is that y a plain old variable? No, right? That y is a function, so I have to leave it with the y prime. Okay? So that's, when I go to write this, it's just going to be 2y prime. And then the last thing to do here is I have a constant, 25. And what's the derivative of a constant? It's just 0. So all that's going to be equal to 0. So right here, I found the derivative implicitly. Well, yeah, implicitly. Implicitly. Okay, implicitly. But that's not all I was asked to do. I was asked to find y prime I need to isolate the y prime. So I found the derivative implicitly. Now get y prime alone. And that's just some algebra. This is just algebra happening out. If I wanted to get y prime alone, what would I do? Let's see. I would subtract the 2x on both sides. That would give me 2y prime equals negative 2x. Then I would divide both sides by 2y. So y prime would just be, ooh, it's negative 2x over 2y, but that if I type that in my math lab, it's going to count it wrong. It's going to give you that really annoying message that your answer is correct, but it's not completely simplified or whatever that thing is comes up, because I have a 2 divided by a 2. Any non-zero number divided by itself is 1. So my y prime is actually going to be just negative x over y. So it's weird. We have a derivative. We have a derivative that has 2 variables in it, and we've never seen that before. Never seen that before in here. It's weird. Let me shrink this down a little bit so I can write it prettier. So I'm going to let your brain absorb that for a minute. Okay. And I'm debating whether I have time to explain what's happening here. I think I do. Okay, so I just wanted to show you, since we've never seen anything like this before, where our derivative, y prime, has 2 variables in it. The reason why that's happening is because our original equation was not a function. It was a circle. So I wanted to just briefly go over this. This is extra info. You don't need to know this, but a circle is definitely not a function because it fails the vertical line test. If I put a vertical line through a circle, it crosses at more than 1 point, so it's not a function. Okay, but what it does, what that derivative does, my y prime was negative x over y. What it does is it locates or calculates the derivative of a tangent line at a specific ordered pair x comma y. So for example, let's just look at one of these. At 3 comma 4, let's locate that point on the graph. At 3 comma 4, right there. Okay, at this point, 3, 4. The tangent line there would have a negative slope. And what this is what y prime does is it calculates the slope of that tangent line. So if I plug 3, 4 into y prime, let's see what we get. Then y prime would be negative. The x coordinate is a 3, the y coordinate is a 4. So this slope right here would be negative 3 over 4. Okay. Negative 3 over 4. But at the input 3, there's another, so at the input 3, there's another point down there. Right? Because it's not a function. There's another point down there. So if all I knew was that x was 3, I could have 2 points. I could have this point up here, or I could have the point down there. That's why it's not a function anymore. So it could also be this tangent line. And that's the point 3 comma negative 4. So now let's plug 3, same input 3, but now I'm down at negative 4. Plug that into y prime. So if we do that, then y prime would be negative x coordinate over y coordinate. And you end up with a double negative there. So the slope of this line would be 3/4. So it's just basically, we're working with more complicated equations now that might not necessarily be functions, mathematical functions. So we just have to have this implicit differentiation to be able to calculate more complicated derivatives. So this is just an example. If that went over your head, that's okay. I won't ask you this on a test or anything. You don't need to know how to graph a circle. You don't need to know how to read the graph of a circle. I just wanted to show you with an example that you might have seen in college algebra with what's happening with this calculus right now before we start applying it to business stuff. Okay, let's work some more examples. Deep breath.
quick question.
Oh, sure.
Back
Go
on
ahead.
the formula, when we divide the 2y, is that because it was right next to prime y and we had to divide it out? Is that right?
Let me come back up here. Oh, yes. So basically, what I did right here, this was the implicit differentiation part, but then we were asked to find y prime. Yes. So since y prime, to get that by itself, it's just like solving any algebra equation, you have to undo the order of operations. So I had to subtract first. I move that to the other side, and then you undo the multiplication. So since these two, the 2 and the y were being multiplied to y prime, I had to divide it off to reverse that operation.
Okay, thanks.
Any other questions or comments on this one before we try another one? Okay. Again, you might not even know what questions to ask yet, but I promise if you have a question, at least one other person is thinking the exact same thing or has the exact same question and they're not being brave enough to ask. So advocate for yourself, be the brave one. Go ahead.
So, since it's saying to find y prime, that's why we keep that y, like whenever we're solving in part A.
Yes. So I, on a quiz or test, am always going to give you this extra piece of information right here where I'm telling you y is a function of x. Like I'm giving you that notation so you can see the input. You can see x as an input, so you know x is an everyday plain old variable. But on MyMathLab and in the textbook, they're not always that nice. So in your instructions, they might just say, use implicit differentiation to find y prime. Done. That's it. So you'll have to know that if they just ask you to find y prime, that means you're treating the other variable like a plain old variable, and you're treating y like a function. But I feel like that's kind of a stretch, so I'm going to give you this extra information that'll tell you y is a function of x. So you'll know x is a normal everyday input variable, treat it like a normal variable, y is the function. But MyMathLab not. And I try to go put instructor notes, like when you open a homework problem, you know, a note pops up sometimes. If it didn't give you that extra information, I tried to put a note in there. I hope I did it. Let me write that on my to-do list to double check that when I copied the assignment, it carried over. So check instructor notes. But just to give you that extra information about the function notation. Right now, that probably didn't make much sense, but let me show you on the next one. So let's look here. We're going to skip this front part because it's just proof by example. I'm not going to go through that right now, but let's do some more problems here. Okay. So this is what I mean to follow up on Trinity's question. So this question right here is asking us to use implicit differentiation. So when you see use implicit differentiation, you have to work with the function. So work with the given equation or function, whatever they happen to give you. It's usually an equation. As is, as it's written. Don't do anything fancy. Just, you have to work with it the way it's given to you. Okay? And what MyMathLab might do is they might just say, find y prime and stop. I'm going to give you this extra information with function notation. The reason why I'm going to do that is because it helps you see that x is the input variable. And if x is a variable, then we know that x prime is going to be a 1. The derivative of a plain old variable is 1. And it also helps you see that y is a function. So then that tells you that y prime is not going to be a 1. You're going to leave it y prime. So they're asking us to find y prime. They may or may not on MyMathLab give you this extra info, but I will on a quiz or test. And then after we do all that, then they're asking us to evaluate it at a certain point. That just means plug in those 2 points. X is 1, y is 0. Okay, so let's see this in action. I'm going to rewrite my equation exactly as it's given to me. X to the 5th minus y equals e to the y. That is nasty. You could not get y alone if you wanted to. See how my y is in two locations here? My y is on the left side of the equation and it's in an exponent on the right side of the equation. No way am I getting y alone on that. Got to do this implicitly. Oops. I just erased the whole thing. Okay. Y. So let's do it. Let's take the derivative as is. I'm going to take the derivative of the left side. I'm going to take the derivative of the y side. Or right side. Okay, here we go. Okay, piece by piece, taking some derivatives. The derivative of x to the fifth, that's going to be power rule. I'm going to remember that x prime is 1 because I'm treating x like a plain variable. So drop the exponent down to the front. Rewrite the base. Decrease the exponent by 1. And technically tack on the derivative of the base. But the derivative of the base is just 1, so I don't need to do that. This right here, that is just a 1. Okay. Okay, so minus, then I come over here to my next term. My next term is just a y. Is y a variable? Nope, it's a function. So I have to remind myself that y prime is not a 1. I'm going to just keep it. What's the derivative of y? It's y prime. And that's going to equal what? So over here, for this very last term, for this guy, I need to use my base E rule. So I need to use the base E rule. Remember that rule said if you have e raised to a function, then the derivative is e raised to the function times the derivative of the function times the derivative of the exponent. All right, that's your basic rule. Okay, so let's do that. So if I start with e to the y, the derivative is e to the y, but then I have to tack on the derivative of the exponent. So your rule says you rewrite the exponent, and then you tack on the derivative of the exponent. And you have to know that y prime does not equal 1 because it's a variable. It's a function, not a variable. And that's the calculus. That's the implicit differentiation. I took the derivative of both sides. I treated x like a plain variable. I treated y like a function. So let me pause here, give you a chance to catch up, catch your breath. Oh, Trinity, I didn't see your hand was up. Or wait, that was old. Sorry. Any questions or comments on what I've done so far? Okay, let's keep going. So that's the implicit differentiation part. Now we need to find y prime. So now I need to get y alone. So now get y prime equals something. So get y prime alone. Well, that'll be fun, right? Because y prime is on both sides of the equation. So here's y prime. And here's y prime. Okay, how are we going to get those alone? I shouldn't call this. We're going to have to get the y primes on the same side of the equation. We're going to get the y primes on the same side of the equation, and then we'll isolate it. So what do I mean by that? Okay, so I'm going to put a little note. I'm going to get y primes on same side. So let's do that first, on same side of the equation. So let me write that out here. It doesn't matter what side you get them on, but the easiest thing I think to do in this case would be just add the y prime on the other side, right? Just move that over there so I don't have to relocate the 5x to the fourth. So I'm going to have 5x to the fourth on this side and y prime plus y prime on this side. Okay, but I need to get the y prime in one location. The y prime is still in two locations. So you're going to factor out the y prime. So you're going to get the y primes on the same side of the equation, then factor out the y prime. So I'm just going to factor the y prime out of there, and then the y prime will just be in one location. Okay, and then to get the y prime alone, I just need to divide by that binomial. So now see how my y prime is in one location. I'm going to highlight it just to show myself it's in one location now. That y prime is being multiplied by a binomial, so all I need to do to get it alone is divide by that yucky binomial on the left, divide by the yucky binomial on the right, and then as awful as that is, God, I did not give us enough space on this. I don't know what I was thinking. Then I get y prime is this numerator over that binomial denominator. That's what my y prime is. So I was just doing algebra. I got y primes on the same side, factored it out to one location, divided off the binomial to get it alone. But are we done? I don't know. Let me go back. I forgot what the problem said. Let me see what up here. What did my problem say? My problem said, use implicit differentiation to find y prime. We found y prime. Oh, and evaluate it for 0, 1. So now I need to plug in x equals 1 and y equals 0. Okay, so we need to plug that in. Okay, so let me come down here and do that. So evaluate at 1, 0. The input variable comes first, the output comes second. So x is 1, the function output is 0. Okay, so let's plug that in. So now we need to plug that in. So plug in x equals 1, y equals 0. Okay, so y prime is 5, 1 to the 4th over e to the 0 plus 1. Okay, so y prime, if I do 5 times 1 to the 4th, that's just 5 in the numerator. And any constant base to the 0 power is just 1. So in the denominator, I have 1 plus 1 is 2. So this is the derivative at the point 1, 0. If I could graph that function, or that equation, if I could graph that equation and on the graph I could locate the point 1, 0 and find the tangent line, that would be the slope of the tangent line at the point 1, 0. You'll notice that this home...
I'm sorry, I have a question.
Yeah, go ahead.
When we factored out the y prime, where did that 1 come from?
There is...
I thought y was not equal to 1.
The derivative of y is not equal to 1. That's correct. The calculus stopped... Let me hold on real quick. Where did it stop? The calculus stopped right here. After I took the derivative of both sides, that's where the calculus stopped. So all I'm doing here is algebra. And so when I was factoring out that y, there is an understood coefficient of 1 in front of that y prime. So when I factored the y prime out of the first group, the e to the y was left. And when I factored the y prime out of the second group, that understood coefficient of 1 was left.
Okay, thank you.
Cool. Any other questions, y'all? Anyone need to unmute and just scream like really, really loudly? Or like slam a book or something? I know this is a lot. No? It's so hard to teach this section without seeing your faces. So everyone go to your status or to your chat room. Either give me a status or give me an emoji. I have no idea. You know, Shayla's thinking this exam is going to be harder than the last one. It's a blessing and a curse. Test 1 is usually what I call bimodal. Either you ace it or you bomb it. And test 1 has a lot of different topics. It had limits. It had the 4-step process. It had derivatives. It had all these business concepts. So that's why it's so bimodal. It's all over the place. Test 2 is just derivatives, y'all. It's all the derivative rules and the implicit differentiation that we're doing today. And we're doing it again in a different context next class. So I don't know. I think you're going to be okay as long as you stay up with the homework. Oh, Belinda's eyes are spinning. I think you're going to be okay. Make sure you're reaching out and getting help. Like I have students, there's some regulars that come to office hours and we just go through homework questions together that they've had. Now they've tried the homework, so they know what questions to ask before they come. They don't come cold turkey because you got to use your time wisely. But it's math is a language. You got to talk it out. So if these ideas aren't making sense, come to office hours and we can just talk through problems. I'll have you lead me through a problem and I'll let you go until you say something wrong. And we can talk about why it was wrong or something. So deep breaths, poker face. Uh-oh, Priscilla says she's got a poker face on. Okay. We're going to do some more. Don't worry. It's the same derivative rules. We're just having to train our brain to read the equation implicitly. We have to slow our brain down and say, before I even start this derivative, what are these letters acting like? Are these letters acting like variables? Are these letters acting like functions? What's happening here? You got to get that in your brain first before you take the derivative. Okay, let's do another one. Deep breaths. If I ever use these notes again, I need to give us more space on that one. Okay, here we go. Use implicit differentiation. So right away, your brain is like implicit, as is. Don't change the given equation. So this means as is. This means use given equation as is. And then we're being asked to find y prime, and that's it. Find y prime. So my MATLAB might stop there. My MATLAB might say find y prime. I'm going to give you this extra information. And what does this extra information tell us? It tells us that x is the input variable. So we're going to treat x like a plain variable. So if you see an x prime, that's going to be a 1. And it tells us that y is a function. So treat y like a function. That means y prime is not, if you're doing calculus part, y prime is not a 1. Okay, so I'm going to rewrite my equation as is. Can't do anything fancy with this. Plus, I couldn't do anything fancy even if I wanted to, because see how my y is in 2 locations? One time my y is a base and over here it's an argument. Like you couldn't get y isolated. You could not make this equation say y equals something and then just take the derivative. You couldn't do that even if you wanted to. So you have to do it implicitly here. Okay, so let's go ahead and do that. So implicit. Here we go. So I'm going to take the derivative of the left side and the derivative of the right side. Okay. Here we go. Piece by piece. Let's go down the row here. Okay. X squared. That's power rule. You don't need chain rule because x prime is going to be a 1. So hopefully by now you can just see that the derivative of this, it's 2x times the derivative of the base. Technically 2x to the first times the derivative of the base, but again, the derivative of the base is just 1, so we're just going to write that as 2x. Minus, now again, I'm going to do the, oh, go ahead.
So right here in the step,
Uh-huh.
where you multiply 2x times the derivative of the base, because you treat x like a plain variable, if it weren't 1, we would still treat it like 1?
So if x is a plain variable or t is a plain variable or whatever input variable they're giving, the derivative of that is always going to be 1, because where that comes from, just a little side here, is from algebra. So like, for example, if I gave you this equation, y equals 3x plus 5, you know how that's, 1, 2, 3, 4, 5. That's a y-intercept of 5, and the slope would be up 3 over 1, right? So the derivative of a linear function is the same as the slope of that function. So with that, from that algebra idea of this like y equals mx plus b, where the slope is the same as the derivative, if my y was just equal to a plain x, if that was the case, then that's a slope of 1 and an understood y-intercept of 0. So that's just your identity function. Y equals x is just the identity function. And the slope of that is a 1. So the derivative of a plain old variable, you're assuming a plain old variable is a linear function with the identity function. It's the slope 1, y-intercept 0. So we just have to train our brains that anytime you have a derivative of a plain old variable, it's just going to be a 1. And it doesn't matter if it happens to be a plain old t, the derivative of a plain old t is going to be a 1. If the derivative, or if the variable is a price, then the derivative of a price would just be 1. If that variable is acting like if that letter is acting like an input variable, so if the letter is an input variable, the derivative is always 1. If the letter is a function, it's not.
Okay.
Did that help at all or not really?
I think so. I think I just need more practice.
Okay, yeah, just what I've seen help students in the past is before you even get started, just make sure every single time you're doing this step right here where you're like, okay, what in the world is my input variable? Because the letter is going to change. In this case, x is the input variable. If x is the input variable, that's the input variable. That's what you're going to treat. If x is the input variable, you're going to treat it like a plain variable. That's what's going to be the 1. Then if y is the function, because that's what the function notation is telling me, right? This is telling me that y is the function. Then the derivative is not going to be a 1. Just practice that step. Write that on every single problem you do over and over and over again and train your brain, because you can't take the derivative until you know what the letters are acting like. Is this letter acting like a variable? Then the derivative is 1. Is this letter acting like a function? Then the derivative is not 1. So
Okay.
it takes practice, y'all. It's a big jump conceptually from like the algebra to the calculus. So it's an even bigger jump if your algebra is a little weak. So make sure you're getting help. Don't struggle. Like, some struggle is good. Too much struggle, not good. Get help. Okay, cool. So let's keep going. Okay, so just to recap what my train of thought was here, I took the derivative of this first piece. The x is, that letter x is acting like a variable, so I knew the derivative was 1. Now I'm moving on to my next piece, this y squared. That letter y is acting like a function. So I'm still going to do my power rule because the exponent's constant, but in this case, y prime is not going to be a 1. So when I go take this derivative, I'm still going to do my power rule, drop the exponent down. I'm going to get 2y prime, and I'm going to leave the y prime there because it's not a 1. Okay, and then in this last piece of my equation here, I'm going to use my ln rule. So let me come write that rule to the side. We're going to use the ln rule. So the general rule said this: if your equation is the log of some function, might be a plain variable, might be a function, then the derivative sends the argument to the denominator, but then you tack on the derivative of the argument, right? That's your plain chain rule for natural log. Okay, so when I come over here to do this, if I have ln of y, my derivative rule sends the y to the denominator. Then I tack on the derivative of the argument. And I know that y prime is not going to be a 1, so I'm going to leave it there. Okay, so that's where the calculus stops. This is the implicit differentiation. So this right here, all this is the implicit differentiation. But is it asking us just to do implicit differentiation? No, it says do implicit differentiation to find y prime. So if I stopped here, I'd get it wrong because I need to isolate the y prime. See how the y prime is in 2 locations? I need to get that alone. So I need to get them on the same side. Okay, so I'm going to write a note. To find y prime, get y primes on same side. Then factor out y prime. So just like before, we've done this. We need to get them on the same side. So let me actually rewrite it so I'm not writing over my derivative step. Oh, I remember why I put this problem down on here. What's the ugliest part? I mean, there's a lot of ugly parts, right? But what makes this implicit differentiation like especially ugly? Like, isn't it this fraction? Isn't that fraction like especially gross? Like, no fraction. So there is an algebra trick you can do, and I'm going to show it to you because it just makes it look so much prettier. You don't have to do this algebra trick, but it's a really nice one. It's called clearing the fractions. So clearing a fraction is a way we make an equation look prettier. It doesn't change the value of the equation. It makes it equivalent but look prettier. So if that denominator, 1 over y is yucky, you can just clear the fraction. So I'm going to do that just so I can review that algebra skill real quick. I'm going to multiply both sides by y to clear the fraction. Okay, so I'm going to multiply this side by y, and I'm going to multiply this side by y. So when I distribute y to the first group, that's going to give me 2xy minus, then I'll distribute y to the second group. And remember, we have a rule in algebra that says you can multiply the left-hand side by any number you want except for 0, as long as you multiply the same number on the other side. That's all I'm doing here. So when I multiply y to the next group, I'm going to get 2y squared y prime. And then when I multiply y to this group, the y's are going to cancel out, and then just leaves me a y prime. It just looks prettier. Then you don't have to deal with that fraction, which it's hard. Basically, it's hard to type fractions into my math lab. It gets really messy. And we'd end up having a fraction inside a fraction, which is just yuckier. So that was just algebra. Okay, so now we need to get the y primes on both sides. So let's go ahead and do that. So I'm just going to add this term that has a y prime. So here's a y prime, here's a y prime. I'm just going to add it to both sides to get them on the same side. So 2xy is left on that side, and I'll get y prime plus 2y squared y prime. Okay, and now my y prime is still in 2 locations, so I'm just going to factor it out. That's going to be 1. Oh, sorry. I'm factoring out the y prime. So there was an understood 1 coefficient in front of the y prime. If I factor it out, that 1's going to get left. And then in the second group, if I factor out the y prime, I'm going to be left with a 2y squared. Okay, so once you factor out that y prime, then get y prime alone. So if y prime's being divided by a binomial, multiplied by a binomial, I just need to divide. And that's my derivative right there. And y'all, I know class is over and there's still 2 examples in the notes. So I think what's happening in class is there's a lot of algebra questions being asked, and in a normal semester, I would probably say you have to come to office hours for me to answer that, or because it's prerequisite material. And I've been spending a lot of time answering algebra questions, but I think it's important because it seems like a lot of students have the same kind of algebra questions. You can't move on in the calculus if you don't know the algebra. But it also means we don't have as much class time to do more and more examples because each example takes longer. So I'm going to post videos for the 2 problems left in the notes. Number 5, put yourself a note here. You need to watch the video for number 5. And then it's up to you to come email me, get help in office hours, go to a tutor if you have any questions on it. Because we need to make sure we're keeping on our calendar. And I don't know, can I just ask real quick before y'all go, does it help me to answer the algebra questions in class, or would you rather me skim through the algebra? Okay, so some of y'all are coming from business math. Okay, so y'all are okay with me slowing down on the algebra, but then that might mean you have to watch a video outside of class if we don't get to everything?
Yeah, I'm fine with watching a video because if we don't understand the algebra, it's kind of hard. We'll mess up.
Okay, I just want to make sure you're okay. So definitely, if nothing else, watch the video for number 5. But I'll post videos for the other problems that were left. Okay, so I'll get those. It might be tonight once I get my kiddo to bed, but I'll get those. Oh, Amanda says she watches them anyway. Okay, I just wanted to make sure that no one was angry. Okay, cool. So I'm going to post videos for the rest of these notes. I'll post the answer key for the notes. Talk to me. Email me. Talk to Madhavi or the tutors if you're having. This kind of stuff the tutors can help you with because it's not business related. Okay? Okay, bye guys. Deep breaths. Oh, Trinity, go ahead.
Have a good day.
Okay, bye.
Hey, Kelly. I have a question.
Sure. Go ahead.
With that previous problem,
Mm-hmm.
instead of clearing the fractions, would the 2xy over 1 plus y squared for y prime
Mm-hmm.
be equivalent to 2x over y, or 1 over y plus 2y? So instead of clearing the fractions, you would just go ahead and continue?
Yes. So let me just do that real quick. The thing is, it's hard to type in MyMathLab because what's going to happen is you'll still get the y primes on one side, right? So
Yeah.
I'm going to get 2x equals 1 over y prime plus 2y, y prime. You're still going to factor out that y prime, but see how you have 1 over y plus 2y left? So when you divide that off both sides, it just gets really, you have to be really careful typing it into MyMathLab because you have a fraction inside a fraction and it can get just really nasty. And plus that skill of clearing a fraction is going to make our lives easier on test 3. It's not necessary. It's just it simplifies stuff later. So I thought I might as well sprinkle it in now to plant the seed now. But MyMathLab will count this answer correct if you leave it 1 over y.
Okay, cool. No, I prefer the clear fractions action or answer because it looks better. But yeah, I just wanted to make sure I was doing that part right.
Yeah, MyMathLab will totally count it right. You just have to be really careful to type it in.
All right, thank you.
Okay, bye, Michael. And then Trinity, Trinity, go ahead.
So, I missed the first part in class whenever we usually talk about what's due and whatnot. I guess I'm just a little bit confused on like what's due and everything. I think in the chat, because we have a group chat for
Mhm.
business calculus, and someone had said that there'd be no late